Good morning and welcome to the CADclass Podcast. I'm Josh,
I'm Jake.
and each week we answer your Fusion360 questions, talk about what's going on in the Discord. We've got some cool projects to show off, detail some weird stuff. We had an odd book fiasco this week, so
We had a
stay tuned for
really,
that
really
one.
funky one. The first misprints that we've seen on the other side of the world in New Zealand.
Yeah, so
Weirdest thing.
we're going to show you what that was. I don't know what I actually did. So I didn't tell you this yet, Jake, but I actually did get in touch with him. He removed his review. We got a 1-star review. I was like, oh no, we can't have a 1-star review for something we can't control. Anyways, good morning, Sam. I want to shout out some people in the chat over there. Good morning, Sam. Good morning, Joe Street, PC Van Vliet, Mr. Mitnick on the Discord. We said Sam
Nice to have you,
already.
everyone.
Maple Leaf Makers. I love the having this activity before we get on. I don't know about you, Jake, but it like really brings. It's like it
is really
excites
nice
me.
having a nice little community. Yeah.
Yeah, and
lovely.
especially like before we even press the go button, there's already this like chatter going on. So thank you all for hopping in a little bit early even and starting to talk, because as Jake and I are preparing, like, oh no, what are we gonna do today? Just before this podcast, we see your comments come in and we realize it doesn't matter. We're here to hang out with you. So thank you
Everyone.
for coming in. So let's start with the book fiasco, and then maybe shout out some projects. So
Yeah.
did you see? You have a picture of that on the Discord, right?
Yeah. So we
Check out
had
this weird.
so we had someone leave us a review on our Amazon page, a 1-star, and it was when that happens, it's like, what? What's going on?
Yeah.
And
Yeah, excuse me. It's not a perfect book, but like 1 star. Come on.
And it was essentially someone saying, I got the wrong book.
Wrong book.
Yeah, check this out. So they got our book, and then inside the book, the only beginner freeze drying book you'll ever need. And I absolutely agree that this is the only freeze drying book that you'll ever need. I can't imagine needing any more than one freeze drying book.
I think we should
that's hysterical.
try to find
That's
that
amazing.
book. What do you think? We should try to
know.
find and buy that book. And maybe
see how many ratings it has.
Maybe what happens when we buy that book is we'll get their book cover with our book inside.
I know. Maybe someone's going like, I'm so excited to start my new hobby of freeze drying food. I want to make astronaut ice cream. I'm so excited. And then they get a book about CAD and they go, damn, maybe this is the universe telling me it's not a good investment.
But
weird. Bizarre.
Yeah. So sorry if you guys see anything or hear anything like that. Let us know, because we actually have no control over Amazon Print on Demand. They handle 100% of everything for us. Huge props to Amazon, by the way. Like they've been really awesome to do the print on demand stuff for us for that specific thing. But that was like, we have no control over that. So that book shows up and we get that bizarre review, and I'm like, great, what do we do? So thankfully we have the Discord, because if we didn't, I don't think we'd ever found him.
No.
Right, that person, we would have never found that
sending him out a book pro bono.
PC Van Vliet says, I couldn't find the freeze dried chapter in my book. Disappointed. Yeah. We should. Oh, you should. So Joe Street, I think I'm gonna do that. So you're gonna see those books behind Jake's, like just behind Jake's left shoulder there, the Mastering Fusion 360 books. We're gonna remove one from that pile, and we're gonna add a freeze dried.
Put in a freeze dried book,
and only you guys will know why that book is there. So
yeah. Oh, it's ridiculous. But yeah, if any of you guys ever get our book, or for anyone, and it has any like major print errors, please tell us, because then we'll reach out to Amazon and go, hey, what the hell is going on?
Yeah, what are you doing?
What is going on?
Come on. What have we here?
Crack the whip. Come on, guys.
Yeah, so weird, so bizarre. So Sam says, Jack and Luke are tuning in. Jack and Luke, it is awesome to have you guys. We hope you enjoy making things alongside of us, and you're inspired by the community. And just before we get into it, I had another conversation. So Maker Faire this past year, we haven't talked about this in a couple of weeks, but Maker Faire was like such an amazing experience. So we actually have officially just about started our partnership with Maker Nexus in San Francisco. So they're going to be partnering with us to bring some CAD classes to their students at their 30,000 square foot makerspace, which is super rad. We met them at Maker Faire.
So if you guys are in Silicon Valley, check out this makerspace. It is awesome.
It's
It is
really, really cool. It's a nonprofit. It's funded in part by Google. It's in that little Google complex. Really cool space. And then there's another one called Human Made. And that one we're probably going to partner with the guy who runs that here in the next couple of weeks. We were supposed to talk to him yesterday, but he's got the flu. Sounds like a lot of people are sick. And then we get to meet just all of these amazing people as we go. And there was one in particular. Oh, yes. So this guy Brandon, who works at a carbon fiber layup lab. They make parts for like helicopters and planes and a lot of
super casual stuff.
As you do, right? So he toured me around the facility yesterday, and we got to talking about some of the later projects coming down the line. His entire job right now is to go from sketch to manufactured product, and he does it over the course of like 6 months. But one of the things Jake and I are talking a lot about is once you guys have learned how to make things in CAD, and once you've made them on a 3D printer, what's the next step? What is the next thing that we want to do? So Jake, the next thing that I think we want to do, at least this is probably like mid-year next year, so we're not getting ahead of ourselves here, but is to teach you how to make a product from start to finish that you then have to source parts from Amazon, from local suppliers, from custom manufacturing. So you have to order maybe a laser cut part, and you have to order a 3D printed part if it's carbon fiber or something like that. And you maybe even have to order a milled part, and that you learn how to put everything together so that when you come up with those ideas, those harebrained ideas, and you go, I don't own a $50,000, $100,000, $1 million milling machine. What do I do?
And also, even if I did, I don't know how to use it. Which is like, it's like the weird thing about makerspaces is that obviously, paying like $100 or a couple $100 a month compared to buying all these tools is an unreal deal. But the kind of bait and switch a little bit is that if you don't know how to use these tools, obviously you have to take classes for it for safety reasons and insurance reasons. That's fine. That's just something you have to accept. But coming into a new tool totally fresh, and then coming into a new tool totally fresh, and then having to learn how to use it physically, the machine, and then how to actually make a successful part on it. Like having access to a CNC mill, that's fantastic. Taking the classes, like you go, oh, I know how to load in a bit of metal, how to home it, how to cut it, how to start a job. That's fine. And then they just send you on your merry way, and actually learning about, well, what are the feeds and speeds of cutting? What are the different directions? What does this mean? What does that mean? It's unreal. It goes from going, oh, I only paid like $200 a month to use this makerspace, maybe $100 for the class, to then months it takes to really successfully learn how to use CNC mills. Laser cutters are a little easier, but
yeah.
Learning design software, that takes a significant amount of time. So literally sending it off to people, even though it can be like $1,000 sometimes, it's oftentimes a lot cheaper than you learning how to make it yourself. Unless you want
Look at this.
And it's like,
we've got Thor coming in from Dubai. What's going on, Thor?
Let's go,
nice
man.
to have you. It makes me so happy that you guys call in from all over the world. Sorry, Jake, keep going. I know I'm interrupting. Go.
How dare you? Yes. So literally reaching out to companies like Send, and saying, hey, can you manufacture this one part? And they go, yeah, it's $1,000. It's obviously like, ooh, that's a little bit of chunk change, but actually reverse thinking, like, make space, learn how to use the tool, learn how to CAD up, learn about all the intricacies and the metallurgy that goes into it. Oh my gosh, you'd be spending way more than $1,000 of your time.
So two thoughts I have, right? So one of them, as I was talking to Brandon yesterday, one of those thoughts is part of the nuance of making things that those companies make is slight design changes actually make a big difference for how much the part costs. So one of the things that I really want to help you guys understand is like, it's not just designed for a thing to be made. It's designed so that you can make it cost effectively.
Yeah.
And so like, as I was talking with Brandon, he was saying like, cause they're actually a partner with his company with Xometry. And so they've got this like $200,000 Stratasys, like amazing machine, right? They'll print all kinds of materials. They're a partner with Xometry. And he was saying what happens all the time is people will send him a part and it's literally like $100 more expensive than it needs to be because it has a fillet or a chamfer in the wrong spot, or because it has this weird bitty geometry. Or like there's this one design feature that makes it super expensive. And so we were kind of talking through, it's like, yeah, it's like helping people understand what are the kinds of end use decisions that you can make to save you time, to save you money, to actually get your part made in the way that you think it's made. So like that's like I'm definitely excited to dig into that.
I think a good little a little bit of a what's the word? I guess understanding is that people who are machinists, who obviously make the parts that are designed by engineers, there's usually a pretty intense amount of annoyance from them because they go, well, the engineer doesn't know how this part is manufactured.
Grumble,
and so
grumble, grumble.
they have to go back and forth because this engineer has done all the math of this is what this part needs to be, but then they don't know how it's manufactured. And so these machinists are like, this is a part that is literally impossible to make. Geometrically, it's impossible. And so they have to go back and forth, back and forth.
Mm-hmm.
So I would say if you're wanting to get a part that's made by a laser cutter or a CNC router or a CNC mill, if you can just talk with some of these with some of these technicians and machinists and manufacturers and say, what are the annoyances? What are the things that you get parts from other people that are completely wrong, and why are they wrong? That will give you a speed run through all of the different design criteria that you then need to change for your design.
100%
I think
agree.
I think a great little thing.
I think people don't pick up the phone and call the manufacturers often enough. They don't call the experts often enough. They don't reach out to their network and talk to their friends who do this often enough. I 100% agree. And PC Van Vliet says CAD skills are going to be the new carpenter/builder skills. I think they already are. Obviously, you need some carpenter. You need people to be able to do the end use stuff that is a little more highly customized on site. That makes sense, right? But like Jake and I have been screaming about this. It's like CAD is as important as code. We're on our computers all the time, learning how some basic ideas of coding and building that in. We've sort of accepted that, at least here in the US, that's important. But we haven't yet accepted this idea that learning how to make 3D models is as critical as learning to code, or and honestly, I don't quite put it in the same category as like learning to write or learning the first basics of math, but it's just after that. It's like, there's a reason, I think, when you're a kid, there's a reason why a lot of us we gravitate towards putting things together, like Legos and toys and IKEA furniture, and like there's a primal sense to it. So I'm like on this,
that got very philosophical, Josh.
Yeah,
I always get a little a little over ends when I hear like professional woodworkers that like really put their nose up at IKEA. Oh, trash.
Oh, yeah.
I wouldn't even go into an IKEA. IKEA's awesome. It's like adult Lego. It's the best. Like the reason that I got into woodworking is because I loved building IKEA furniture, and I still love it. Okay. This is something that is on my bucket list. I think in Sweden, I think in a few European countries, there are competitive IKEA building competitions where they give you like a Malm bookcase or whatever, or Billy bookcase or whatever, and it's like
Billy
time
bookcase.
trials. How fast can you make this bookcase? And I want to do this so badly because I am the family member on both sides where if they need to make a bit of furniture, they'll just go,
give it to
bring
me.
Jake over, and he likes to do it. I'm like, I do like to do it.
I also like that. I was at two very quick stories for me. One, I was at the sister-in-law's place, right? And she had a piece of assemblable furniture. And I was disappointed because all I had to do was screw the legs on. She was like, ooh, furniture. I was like, oh, I'll do that. Like, let's.
Josh is a woodworker. We'll bring him in to assemble.
Yeah. The other thing I'll say, and this is really funny. So when Jake was visiting here in Sacramento, so for those of you who don't know, I'm up in Sacramento. Jake's about 6.5 hours south in Huntington Beach area. I say Huntington because more people know that. But Huntington Beach area, so about 6.5 hours away. So Jake comes to visit, and we go to IKEA. And I gotta say, Jake walking into IKEA was like you just took a kid to his first light show. You walk in, and it's like, ooh, look at all these flashing lights. And
but you're not telling people that this was your first time ever at an IKEA.
That's true.
Which I thought was absurd.
Yes.
You were walking through, and you're like, how does this work? And I'm like, okay, well, there's a warehouse downstairs. And you're walking through, and you go, they have a cafe in here? I'm like, yeah, dude. He's like, oh, those meatballs look nice. Yeah, they look nice. They're IKEA meatballs.
Jake was like a pro. He had all the he knew exactly where
I
to
live
go. And
right
I'm
next
I'm
to an
walking
IKEA.
around in a store. I'm like, what is there's I can just look at stuff up here. I have to go get it from somewhere else. So anyways, Jake,
And you're like,
I digress. I thought that was amazing. I do really like the way they lay it out. So
I don't even remember.
you do know you hit middle.
Yeah.
Middle age, Jake. How's that feel?
I've been middle-aged. I've been excited to go to IKEA since I was a kid. I'm fine with that.
IKEA is amazing.
I go
I'm
on IKEA dates with my fiance.
Yeah, but we're not going to pretend. We're not going to pretend like it's nice stuff. It's like nice enough. But I get the quality side of it. I'm obsessed with quality.
I don't.
My desk is IKEA.
No, I completely denounce that. I still have IKEA furniture that is 25 years old that still works just fine.
Mm-hmm.
Like some of the desks. Okay, if you get an IKEA bit of furniture that's like 1/2 inch or 5/8 of an inch thick, and it's heavy, that will last for decades. If you get like a desktop that's like an inch thick, it's going to be that honeycomb laminate between hardboard. Yeah, that's probably going to break in 5 years or so. But compare that to like a solid wood table. Good God, people, chill.
people, you people. All right, let's do some projects, shall we? Enough of our ranting here. You guys come to watch us make stuff, not talk.
I do have a project that I want to do today, but let's show some people off.
Yeah. And then maybe quickly hop into PC Van Vliet's question, which is that angled extrusion. Let's see if we can figure that out.
Wookie-O or Wookie Ohio has made this really kick-ass project.
It's amazing.
I think it's something for gaming. A Stream Deck.
Oh yeah,
not a gamer. I don't know anything about this.
That looks like a steering wheel for a game.
I have a non-standard wheel stand for my sim racing wheel. Yeah, simulation. Gotcha. I had to make something to keep my Steam Deck nearby, and here's what I did. That is absolutely rad. Making like this little custom thing. I've seen people use or make these for CAD where you can I think it goes to an Arduino or a Raspberry, where you can pre-program in buttons and make custom stickers for buttons. So like a very specific thing or a complicated series of things that you would normally have to click and drag, and this is just a single button. Like that's awesome. That is so rad. So this absolutely kick-ass. Love this stuff.
Love it. Love it. I had another conversation with the city of Sacramento yesterday. So we won the innovation grant here in Sacramento. And I was sitting down and she said, "Hey, so what's the like desired outcome? What are you measuring? What are the metrics?" And I was like, "Look, I'm going to put it as simply as I can for you. People who go through our program, they can do as much or as little as they want, but the moment they start making things that they're genuinely excited to make, and it's not our stuff, but it's like stuff for them, that's a win. That's it. Yeah. That's all I want. If they leave 100%. Excited to make their own stuff, like that is the goal of the program." And she was like, "Oh, yeah. So what about the metrics?" And I'm like, "That is the metric. That's a win."
Continuing onwards with Joestri. Joestri's making some battle bots, some combat robots, which we always love to see. And he's been working on this crawling mechanism, which is just looking more and more rad every single week. I'm so stoked to see where it's rad. From.
Yes.
It's a little dark in the picture, but he's got two herringbone gears going to, this is a reduction gear work. Then into all these kind of funky cam mechanisms. It's basically I think I would describe it like a slug's movement or a caterpillar's movement, essentially.
And that's Joestri. So he's in the chat. So if you got questions for him, by the way, he's there.
Joestri. Yeah. I still need to pick your brain.
He said, ignore the Band-Aid.
Yeah.
I'm not going to ignore that Band-Aid because that is the mark of somebody that's making things. I don't know of many makers who aren't just like full of like Band-Aids and splinters.
Yeah.
And
I have a tiny story. So I was so my fiance is a nursing major, but when she was in high school, she was the person at football games, the medical staff that ran over and helped you off, wrapped your ankle, all that kind of stuff. So she's basically her entire life just been very kind of tuned into, I need to help people. Oh, you cut yourself, broke a bone, I'm here to help. That's all I do. And anytime that I was doing woodworking or metalworking or welding, and I would like cut open my hand, slash open a finger, anything like that, my initial reaction is, oh, just squeeze it and squirt some super glue on it and hold it for like a few seconds, then it's fine, it's done. And because super glue is hygienic. And she had never heard of this before.
Uh-huh. They use it in emergency rooms, by the way.
Yeah. But like I learned that from my grandpa in his workshop. And she never heard of it. And she was like, what kind of backstreet alley medical aid is that? And I'm like, looks fine. She's like, no, it doesn't.
BC Van Vliet says, thought it was to prevent you from sucking your thumb.
Boom. I don't know.
With
I don't
the
know.
dick.
It works fine. It works just fine. But anyway. But yeah, cuts. I think all makers have cuts and scrapes. We used to do.
Totally agree. Totally agree.
Every single time that I was teaching any woodshop class, I'm like, does anyone have any woodshop experience? And the guys and gals that would have experience in woodworkers would just they wouldn't put their hand up like that. They would put their hand up like this, showing that they didn't have all of their fingers.
Like the end was nicked
there
off.
You go.
Like yeah. SawStop, man. SawStop is incredible for its ability to prevent injuries. Like that's up there with greatest inventions of all time for wood shops.
Yep. Can I do a little bit of a Jake rant, if you don't mind?
Oh, I never mind. Let's just go ahead and hashtag Jake rants.
Okay. This is less of a CAD thing. This is less of a 3D printing thing. This is just kind of a workshop thing, which I think a lot of people will recognize. Why haven't we electrified table saws with measuring? Why haven't we done this? I feel like we have made every single tool in an entire workshop modernized, and yet table saws are almost exactly the same than they were 100 years ago. I don't understand what
you said. Electrified them with measuring. What do you mean? What are you talking about?
Okay. Other than the motor, there's no other electric systems on there.
Okay.
Why isn't the actual fence on a table saw? Why isn't that just hooked up to like a giant caliper? So instead of like, oh, this line is like hunched over a little bit, I'm lining up a line with a little mark on a bit of perspex. Like, why? Like, is it me? Why haven't we just like, oh, move the fence up to the blade, zero it out, and then I move it over, and I can get it to exactly 1 inch. To like,
you know what you're making me think of? You're making me think of basically almost like a hybrid.
You can set it on a lathe. You can do it on CNC everything. I feel like it's the easiest thing. Secondly, why are we still hand cranking, raising and lowering, or raising and lowering and then angling table saw fence? Like, as they get bigger and bigger and bigger, they get heavier and harder to move.
Yeah.
So why aren't we just putting like a little crappy motor on there?
Well,
with where you type it in, we go, I need 45 degrees.
I think actually it's probably your idea, but I think it's basically combining the idea of the CNC and the table saw, and the fence is completely programmable. So all you do is type in your number, shoots over to that spot, fires the blade up the thickness. Actually, you could also have some, if you slid your wood up next to the blade, you could have some vision technology, which would just automatically raise the blade just slightly higher than that point. And so you could probably put your wood there, raise the blade, set it with a controller instead, and just zips to the spot that you want to go, locks it in place.
We've had this with mills for like 100 years almost.
That's really interesting.
Where it's like you flick a switch, there's a little speed control, and then it just moves your table left and right, and it mills. Am I crazy? Where you can just type in, I want 45 degrees, enter, and then it just moves your blade? Like, that's easy. Like, why am I the person that's coming up with these ideas? I don't want to invent this. I don't want to be a table saw manufacturer at all. That sounds horrendous. Yeah. How did we get to SawStop technology, which is amazing? Absolutely amazing. How have we got to that before we did 35 degrees, enter? Like, I feel like most table saw cuts, it's going to be at 0 degrees, totally vertical. The annoying bit is if you try and angle your blade and you're trying to get an accurate measurement to the fence, that's a pain in the ass, because you're always measuring the top, or where it's like the sharpest angle to the flat section, not the underside. That will always, or the underside will always stay whatever your fence is. Like, if it's 45 degrees, it's like, all right, take the fence, add the thickness because it's the equal side. anything else is a nightmare. Like, why?
I mean, could you also just
I get angrier and angrier at every single
It's
podcast.
so interesting. Could you also just invert, just basically put a table saw blade above the piece of wood as well, and then just touch the table saw blade off on the actual board, like zero it out that way, and then just, you don't even have to touch. Like, the other problem that I think you have with table saws is that you physically have to put the wood through the table saw. So what SawStop does is they say, well, at least when you do that, there's a safety mechanism here. You're probably not going to lose a finger. But what if you just didn't have to touch your piece of wood at all? What if you just put it up
think
there?
that would be a problem, because some woods will swell and will give you internal stress. So as you cut it, the wood wants to pinch the blade, and that's something that human being can feel, and then go, nah, this bit of wood is wrong. I need to pull it out. And a robot's just going to force it.
I like the Jake Grant. All right.
Yeah.
Onward.
Coming back to
back to life.
back to Discord very quickly.
Yes.
I've got a project that I really want to do. It's not exciting. I don't know why I'm building this up.
Yeah.
But it's something that I want to do.
This was last week, so it's the truth.
Yeah.
They
made the thing. Nice.
So that is some sort of cable holder that he needed to modify last week. We went through the process of, I think there was like a friends don't let friends try to modify STLs. Rant, maybe PC Van Lead. I don't remember who it was, or maybe it was Maple Leaf Makers. I don't remember who, but we went through the process of like importing that, starting to kind of edit some of the STL, and just saying, actually, the way we do this is just to redo it.
Yep, it sucks, but that's usually how it goes. Fantastic.
So it looks like he did it. That's amazing, by the way. I mean, I think he's only completed Maple Leaf Bakers is there. So I think he's only completed maybe week 0 of what we have in the book so far, and he's already making his own custom stuff. So you guys who haven't yet done any of that, you can do it. Also, shout out to Fancy Frog. What a name. Fancy Frog. I love it. Cool.
Absolutely rad. A really quick question in the gear train, which is much later in the course. So the whole point of the gear train project, if you guys haven't gotten to it, is that you essentially make this massive gear reduction system where if you put in enough speed for the first gear right here with just like a normal hobby motor, it reduces that slowly but surely until the very last gear will take a year to make a full revolution. And it's in this kind of tight package. But there's like 17 joints you have to do exactly in order and exactly motion link all of them. It's a massive pain. We'll be keeping the project, but remixing it to make everyone's life just a little bit nicer.
Just simpler. If you want to expand it, you can. Mm-hmm. Yeah.
So we'll just be messing around with this a little bit, because there is some really fun bits of physics in here, which I kind of dig. There's a little bit of math in there, which I like, but not everyone does. But this person's problem, not sure who it is. So as you can see, when they apply an animation to the first gear, it looks like everything's turning fine, but this last gear is kind of funky. This is mirroring the motion of the first one. So I think they just accidentally added on a motion link between this gear and the first one, potentially, and set it to a 1-to-1. So when you turn the first gear at a set speed, the other one is going at the exact same speed. It's a 1-to-1 ratio. But for all the other ones, if you guys can see, this one is a 1-to-4. So when this first one turns 1 revolution per second, this one's turning a quarter. That one's a 16. What is it? 164. And then it just goes on and on and on, reducing until this last one will look like it's absolutely not moving at all. I actually do have a little motor, teeny tiny little hobby motor. Nice. That I've been meaning to 3D print this and actually make it.
Yeah,
I have the files. I just need to make it. But that's a mini project coming down the way in a little bit.
Yeah, if you like mechanisms like this, by the way, check out JBV Creative on YouTube. So he does almost exclusively these kind of mechanistic creations.
If you guys aren't subscribed to JBV Creative on YouTube,
he's
absolutely fun. Check him out. I believe he's a Canadian maker, and he's a 3D printing guy, and he's
Toronto.
Yeah. Mm-hmm. Oh my gosh, amazing products. We got to meet him at Open Source in San Francisco and interview him. Yeah. Such a nice guy.
He was super nice.
So
guy.
Rad.
Yeah.
I love his stuff. He's an artist. And I just
I
envy his work.
I agree with you. Yep, he's amazing.
We had a really funky question from Mr. Mitnick, which I think he's in the
PC Van Fleet is Mr. Mitnick. They are one and the same.
Gotcha. So he says, I feel like a noob, but how do you extrude cut at an angle? I would like to make a 45-degree slot to be able to fix another piece in place. This looks easy, but now that I'm drawing it, I am baffled. So what I think is that you essentially want this top surface to be square, but then actually like a 45-degree angle V cut into it. There's a couple different ways to do it. It looks like you made a sketch for the rectangle, extruded it, and then made another square here. I would do it in a slightly different way, and I'll just do it very, very quickly if you don't mind. So my initial reaction is to make a box. I'll just make it roughly the right size. Yep. And then you were drawing a square on top, and I think Joestry in the comments said, "Oh, you should extrude it downwards, but then with a taper that goes to 45 degrees." You can do that, but you don't get a huge amount of maneuverability, a lot of customization. So instead of actually making a cutout from the top down, I'm going to do a symmetric extrusion cut on either side. Just you'll see you have a little bit more usability in it. But I'm going to do a symmetric cut, which means I need a plane running down the middle. You can see the origin is on this corner. So I'm going to use the mid-plane tool. I'm going to be selecting either side of this box. They'll put a plane smack bang in the middle. I can make a sketch on that plane. You can see the sketch plane is actually running through the middle of it. I'm going to project this top edge just so I have something to click on. Then I can make my 45-degree angle, I guess lines. Add on some equal constraints. We'll make this perpendicular. And then you can make this any size you want. So if you want to make it, or if you know the depth, if you say, it has to be 5 millimeters deep, or I think he said another part is actually going to be cutting into it a little bit.
Yeah, so he's got a little comment here. He said, I would like to make a simple sign with a QR code. For that, it would need 2 parts. I don't entirely know, but I think keep going through this process because I actually think this is still the answer. And then you'll let us know, PC Van Vliet, if that's true.
So as soon as I'm done with that sketch, then I can extrude it because there is only one profile. It has said one selected profile. I can make the direction to be symmetric. And because I'm actually extruding this into a volume that already exists, it's going to be cutting immediately. Yeah. So in the other scenario, I'll actually do it on this side, just so you guys can see the differences. Generally, when it's a simple operation like this, the more dimensions that you have access to, the easier it is, especially with angles. Angles can be kind of a pain to deal with. But as you'll see, if I try to extrude this downwards and then add on some angles to this, it'll actually, like a trapezoid. It's actually a little hard to dial in exactly what is, perfectly cut in. You can see I can set this to negative 45 degrees, but then I've got this kind of flat plane in the middle, and doing the math to make sure that it's a nice tight corner on that can be a little tricky. And obviously, I don't know if you guys can see this. You've now got slanted walls on the left and right, so you don't get those nice, neat straight lines on either side. So, 2 different ways to get almost the same result, but I would refer back to that one. What do you think, Josh?
We just have a graduate in our Discord, so I zoned out to try to highlight him. But
how dare you?
I did not see the second way that you did it.
To whoever
only the first way. It's Snipe. I'm going to put him as a graduate right now. Sniper Ninja Kevin. Okay. All right. Sniper Ninja Kevin.
Congratulations.
So I sent him a note and I just said, "Hey, did you end up finishing the entire course?" He said, "Yes, I did." So we're going to go ahead and promote.
Golf clap, everyone. Golf clap.
So awesome.
These are
we can't wait to you in the chat, by the way. We can't wait for you all to graduate so we can do some balloons and confetti. So sorry. As you were, I was not paying attention to the second operation.
So this is the first way where we essentially made a sketch of a triangle and then symmetrically extruded it either way. And then this is the way that Joestry recommended, where you actually drew a square. If I open that back up. start off with a square and then extrude it into the body with a 45-degree angle. And the problem with that is that you often you don't have a ton of control
interesting. Yeah.
with this flat section in the middle. You have to do a little bit of reverse math, which can be kind of a pain. And then you also have angled walls on the left and right, which you usually don't want. It's a little bit more complicated than you need. And on my method, you just have flat edges. So if you need to have like, a square piece that slots into that just fine. Par example, if you have like a little a different body, duplicate. Let's change the color of that. Lovely. Boom. So if you have another piece that's actually slotting into it, then that just makes it a little bit cleaner, a little bit easier to deal with. But yeah, lots of different ways that you can do this. More than one way to skin a cat, etc., etc.
Oh my god, I hate that saying so much. Oh, we need to come up with like positive, like for some reason I don't even know what the name of that is. That's what is that called? Anyways, PC Van Vliet says, ignore me. PC Van Vliet says, thanks, Jake. Gold nugget. Yeah, it makes a lot more sense. Yeah. And I like the getting used to using that plane tool where it just automatically dissects the body.
Mid plane is, really nice. Is so rad.
I highly recommend. There are multiple ways to peel a potato.
Not really. There's not that many ways to peel. I mean, there's. I can't think of that many ways to skin a cat, but there's only a few ways to peel a potato, surely.
I think it's probably pretty similar.
Anyway, regardless, if you got a lot of those tools in the construct menu, there's a ton of them. A lot of them, the vast majority, I do not use, but there's a couple in there that are absolutely essential. One of them is mid plane, offset plane, and then like axis running through cylinder or whatever. Highly critical. Absolutely do that. All right. I have a project, and I did a prototype last night, and it wasn't a failure, but it got me closer to realizing what I actually want to do with the project. So I'm recording a bunch of data, some really, really huge files. And I have quite a few of these little Samsung T7 SSDs. This is a 2 terabyte drive. It's about the size of a credit card. 2 terabytes for like $100. Crazy. And these things are really rad. I have a couple of these, and they're just kind of dangling off the back of my computer. And I essentially just want to make a little holder for this so I can tuck it neatly behind my monitor and I don't have to deal with dangly cables. I hate that stuff. So I made a little this little box very, very quickly last night, where it's essentially the exact same size as the SSD, but with a 0.5 millimeter offset on all the holes. For anyone that's getting into 3D printing from CAD, what's this?
Just currently a quick question before we hop in too deep to the.
All right.
To the
currently on the American football lesson. I was wondering if you teach us how to do an angled extrusion later in the lessons. Angled extrusion.
Yeah.
I know. I think we do it really, really early on. I mean, if you go back to the fundamentals in chapter 0, we show that you can extrude off at an angle.
Yeah.
But it's not something that I use very often.
No, it's not me neither. That actually might be the only time we show it, is that intro.
Yeah.
Lesson.
It's not tremendously useful. If you want angled walls, use the draft tool. Much easier to work with, much more accurate.
And the draft tool for reference is you did that in the Lego brick.
Yes. Yeah.
Yeah.
Okay. So essentially in the world of CAD to 3D printing, the rule of thumb is that if you want to have a sliding fit, you should have a 1 millimeter offset. That's a pretty good amount of tolerance. If you want to have a little bit more of a tighter fit, then 0.5 millimeters is the way to go. So for this one, I had a 0.5 millimeter tolerance on this, but it was just still a little bit loose in there. Like you can tilt it. It's just not super duper tight, and I don't like that. If I'm going to have this in there, I want it to be kind of a tight fit. But I saw a few people on Thingiverse made these, but they have this little clip mechanism where it's like a little spring, essentially, with a tooth, where if you want to take it out, you just flex this a little bit, and then the drive pops out. And I'm like, that's a great little mechanism. that I think we should go into, because
that reminds me of that.
all the time.
You ever have those guns that actually I think they were like Lego made them, where they had the little like thin piece that you slotted into the Lego, and then there was a
and then you
little
pull it.
clip, and then you could.
Yeah.
Those are so fun. That's a really fun mechanism. So go.
So I think so. I actually realized that I don't think I'm going to go or buy more and more and more of these where I need a ton of these. I think just having 2 of these slots is perfectly fine. I also made these walls like 1.6 mil, so 4 layer lines for the normal printer. And this thing is like thick as anything. It's really not flexing. I don't need it to be so indestructible. That's fine. So I've got a few design elements that I just want to put into place. So I'm just going to be just messing around, really. But I figure this would be a good mini project to show off. All right. So let's make a new tab. Oh, no, that's a lie. I actually did build this last night, so I can actually go in and edit it. This is not the most exciting. Oh, where is this? Oh, it's disappeared. I'm not sure where this is. There we go. Okay. So this is not a tremendously exciting build. As you can see down in my timeline, it doesn't actually take all that long to make. I made a little SSD down here with like a USB cable coming out of the top, just so I have a rough idea for the size. Making a new body that goes around it. But as you can see, I did add in that little bit of clearance in it. So I want to tighten that up just a little bit, but I also want to show you guys a little bit of a weird thing that goes on with this. So this inner slot shape right here, that is the head-on profile of these little SSD. And so I essentially want to make this outer profile right here. So I need to have the outer edge, and then obviously the inner side with 0.25. That would be 0.5 for the top and the bottom for the clearance. Okay. So that's pretty easy. You could go into the offset tool. You'd essentially select the profile that you want to work with, and then you can type in 0.25, and that gives you this inner wall right here. That's fine. The weird thing in Fusion, I'm not 100% sure why you can't do this, but you cannot offset an offset. So as soon as I try and click this, it'll give me a little error that says it already has an offset, which is always kind of funky. So if you want to have an inner and an outer wall where they're both offsets, you actually have to do a little bit of math where you say, all right, I want this dimension, and then however thick you want it. So having 0.25, I don't actually need it that thick. We'll go 0.15. And then as far as the math here, a little bit better, I can actually click this dimension, which will pull up the parametrically driven parameter. So if I ever need to go back and change that, the other one will be updated automatically. And then instead of 4 layers, I'm just going to do 2. So I'll do 3. So 1.2.
By the way, so as you're designing this, this design is for 3D printing. And one of some of the feedback we've gotten, and we may have mentioned this to you all, is you want more information about how to design specifically for 3D printing. So next iteration of our book is definitely going to have some of that dialed in, thinking about the wall thicknesses that you're talking about now, Jake. So definitely coming down the line. So stay tuned for that.
Yeah, absolutely. There was a really funky total tangent really quick. 3D printing nozzles are 0.4 millimeters because some guy just decided. I think the story is that the person that decided that just had that drill bit closest to him, so he used it, and that just became the standard for the industry, which is so silly. And so it used to be is that if you're wanting to make a wall thickness, you'd essentially do multiples of double your nozzle diameter. So you'd make walls that are 0.8, 1.6, 2.4, 3.2, etc., etc. But now that we have different, the problem is that if you had an odd number, if you had 1.2, it wouldn't actually draw the line in the middle. You would just have a layer, an air gap in the middle, and then another layer, and it would just be really, really weak. But now we have programs that fill in the middle. Don't know why that was ever a problem, but yeah, 1.2 is now an acceptable value, which is so stupid. But yeah, then this is essentially just extruded up to that top surface, just fine. Capping off the bottom a little bit just by extruding that down. Again, I put it down 1.6. A little unnecessary to make it so thick. I'll go back down to 1.2 just so everything is nice and even. And then what I wanted to do is add the clip in now, but just really quick. I then essentially patterned them all the way down, but because I changed the thickness of my material, you can now see that I've got a little bit of a weird overlap. So I'm just going to fix that and then undo it really quick. So so the dimension that I actually want, because I want them to share the same wall line right here, is to measure that wall to that wall. That looks like it's 9.59. So when I go into my rectangular pattern, I go 9.59. And as you can see, they now share this inner wall right here. So I don't have to have like double thickness because they're right next to each other. This saves a little bit of material and actually does make it stronger, which is much nicer to deal with. And then I just combine them all together and then added on a little fillet onto the top. 0.6 just to halve it. There we go. So now it's just a little bit easier to put the SD cards in there. But I wanted to add in that little pin slot, which is a little funky. It's a little hard to make. But I think it's a good project to do. So the idea is that you want just a little tooth, basically like a 45-degree angle, and it has cutouts on either side. So it has a little bit of a movability, a little bit of a springing action. So it can snap onto that, and then as soon as you push this tooth back, you can then pull it out. So in this scenario, because we're going to be printing these in this orientation, that tooth actually has to be a little bit wider because the cross-sectional surface area of that layer line is tiny and it wants to break off. So in normal plastic manufacturing, where it's all this kind of uniform emulgus of material, there is no layer lines. It's evenly strong everywhere in every direction. But with 3D printing, we have to change how we design things just a little bit differently. So first off, I'll make the tooth and then I'll make the cutouts as a secondary. For this cutout, I can't make like a normal straight tooth because this profile is on an angle. So I actually need to use a sweeping operation, which means I need to make the triangular profile of that tooth and then sweep it around. So I'm going to go ahead and make a new sketch. I'll try and get an inside view. There we go. Actually, that won't let me click it. So let's turn that off. Click the plane I want, and then turn it back on. There we go. So I'm going to be projecting the inside of that surface. There we go. Getting head-on view, and then I'm just going to be making a very simple triangle. I actually want to make this fairly small, because if I make this too large, it's going to build up too much stress in the print, and then it'll just likely fail. So I'll make this, what, 1 millimeter? That sounds about right. It doesn't need to be too strong, just large enough to kind of grab onto the end of it. That's fine. Then I can take this profile and actually sweep it. So with sweeps, it's always saying what is the profile and what is the path. The profile is this little triangle, and then the path is going to be this entire edge. But I don't need a chain selection. Chain selection means that if this curve is actually tangent to this line, that it will continue on. By unselecting that and just clicking on this edge, it only wraps around to where it's needed. I don't need it to be the entire length, though, so I can actually drag these arrows in a little bit as well. And as you can see with this number, is that it ends at 1.0. So it's essentially like a percentage almost. It's not a distance. And then this type as well. Yep, don't need to worry about that. So a lot of manufacturing, you actually just kind of eyeball things and go, yeah, that's about right, which is always freaky for people. They go, is this how things are made? It's like, yeah, this is how things are made.
Yeah.
It's just like, I can't tell you how many times I'm designing something pretty critical, and I will just hold up a pair of calipers to me and go, yeah, that's about right. Type it in, run a simulation, and go, oh, it works, great. Oh, yeah, that's how things are made. That's how things go. So I'll start off with 0.1. Because this is a percentage, I actually do not know the distance for this, so I can make this and then go back with my measure tool and just check how large That is 1.3 millimeters. It's kind of small. Yeah, I could go a little bit more. Let's whack that up a little bit more. Let's go to 1.5, 1.5. So I've got. Oops, did that not accept it? Yeah, 1.5 and 1.5. Great. There we go. That was weird. What is the total with that? 1.9. Great. That's just fine. And then I can go in and make a new sketch on this top plane. And this is where I can make just a very, very simple rectangular cut into this. Or actually, I'll make it a little bit fancy. I'll make it tangential cuts. Ooh. So I'm going to be extending this out all the way. And the whole purpose of this, I'll make a little cross line as well. So the whole purpose of this cutout is that it essentially just leaves me with this tooth being a long, skinny stalk. And because it has a lot of height, it means it can flex nice and neatly. And so I'll make this a tangent operation. This gap right here, I'm going to essentially be cutting away this material. It doesn't need to be any dimension in specific. It just needs to be kind of loose. So 10 degrees to be cut out. That's completely fine. And then I can mirror these two lines across this point right there. It's a little bit less work. Then now I can go in with my extrude tool and cut away. And depending on how deep I cut into this tooth, is essentially proportional to the stiffness of this tooth. So if I only go down just a little bit, then it means this tooth really can't move all that much. That's going to be a big problem because that's going to be the first part that breaks. So if I go down, there is a certain point where it's stiff enough to where it will move out of the way and then flex back into place, but too low and it'll just break off because it's so floppy and so skinny. This is something in plastic engineering where they have huge textbooks with highly specific values on this. But because this is just a 3D printed part, we can just kind of say, yeah, it's about right. That's fine.
Something interesting here too is when you actually go to print this thing, when you actually go to make it, if I were testing this out and let's say I was like not very confident that little bit right there was going to be as strong as or as weak as whatever, like the flexibility that I wanted, I would probably actually cut this in half and I would just print half.
Yeah, absolutely. So, absolutely.
Going through the process of like, I'm testing a feature, you don't have to 3D print the entire thing. Just cut off.
I'll show you exactly how you can do that. Yeah.
Exactly.
So you can make an offset plane from the top plane that goes up to that point right there. And we can split the body. I want to split it with that plane. Great. And then I can make an offset plane for the bottom. So it only brings up exactly what I need.
Yeah, and then we're just testing the mechanism. Like, I think I use this all the time when I'm, it's like, I don't want to take 10 hours to figure out it's like, I can figure this out in an hour. So, love it.
So now I've essentially got 3 bodies, I think. 3 bodies. Yeah.
I don't know if it cut,
so I've got this low body right there, the main body, and then this is the only pin mechanism in it. So instead of, like, this whole thing, I printed it at 0.16 millimeters for layer thickness. It took like 5 hours. I just printed it overnight, so I didn't really care. But this little pin mechanism, this may be something that I want to make today. So I don't want to print out all of this thing, waste a ton of time, waste a ton of plastic for this mechanism to just fail. So print out just this little thing and you can flex it and you'll see, know exactly. It will actually fail.
Yeah,
or,
exactly.
No, this is totally fine.
Too loose, too tight. How does it feel? Yeah, you get a good sense of it. So, yep, definitely use those tools to cut your parts up. And
100%. Great little tip, Josh, by the way. Not bad. But I don't need these. That's fine. So now we can go back into the rectangular pattern tool to actually make the rest of them. But I don't need 3 of them. I actually only need 2. So let's lower that quantity. Then these are now 2 bodies. Use the combine tool to join them together. Now we only have 1 body. And then just adding on a nice little fillet to this. I could add it to there. Not necessary, really.
Sam says, phone calls. This hour might get upgraded to a do not disturb hour. That's what I'm talking about. I'm talking about.
How much time do we have left?
Oh, okay. Not that much.
I'm gonna do a very, very simple little explanation for some of you guys that are brand new to 3D printing. I would be printing it up in this orientation where the flat section, a lot of surface area, sticking to the build
They can't
plate.
see you, Jake. So let's.
Excuse me.
Oops, that's me.
Gross.
Okay, let's do that for a second.
Can you see me now? I can only see my Fusion screen.
I can see you now. Yeah, I'm just showing us on screen.
So I'm going to be printing it in this orientation where I've got a nice amount of surface area on the bottom that adheres to the build plate. And then I'd be printing it vertically. If I wanted to print it flat, then I would have to support all of these shelves essentially, or else they would droop. So in this orientation, it prints much cleaner, much faster, no support material. Good. The other thing is that when you 3D print things, the first layer often squishes out. And if you can see this, that's a little bit too blurry. But you get essentially a bulging out of the first few layers called elephant's foot, where pressure is essentially being relieved. One of the ways to overcome this is to add chamfers to the underside of a surface right there. If you have this totally flat, it's more likely to bulge out. So adding in some chamfers essentially sucks or pulls away some of that material. So when you are extruding it too much, it'll kind of get filled in the void so you don't get as much of that defect. What a lot of people want to do is they want to put in a fillet. And the problem with this is that it does remove some material from this corner, or there is now a void. So that's good in that respect. But you essentially have like this really, really intense overhang where you've now got a huge amount of droopage in there. So if I just do a very, very quick sketch, you'll see exactly what I mean. If you are printing a 45-degree chamfer, then this line is going off 45 degrees, and all 3D printers can print at 45 degrees. That's just kind of a standard. But if you try and print a completely perfect radius on there, you'll actually run into a few different problems. One of them is absolutely just going to be aesthetically, it'll look terrible. So I'll add a little 3-point arc. So imagine that this is a radius. The problem is for this one, there is no overhang issues. There's no droopage because it can print that 45-degree angle all day long just fine. But with this, it actually starts off at essentially less than 90 degrees. So if I make this or if I completely fix all of this, there we go, and then add on a tangent line just so you guys can visualize the overhang angle, halfway up the print.
It's intense,
yeah, this is totally fine. Let me...
Maple Leaf Maker says, chamfer to 45, then fillet. It's interesting.
yeah, you can do that. Yeah. So later down the print, you're going off almost vertical. This will print perfectly fine. But at the beginning of your print, you can see it starts out completely horizontal. And then after a few layers, it's still at like 90 degrees. And it will just give you this huge amount of droopage, huge amount of bad quality on there. So for the rest of your print, you can absolutely add fillets on there. They look really nice. But for the layer that's actually touching the build plate, make sure it's a chamfer. It'll make your life much easier. Who said to make a chamfer and a fillet?
Maple Leaf Makers.
Interesting. So if I add on a fillet to this top surface... So then that's interesting. I like that.
Yeah. He says fill at the top edge now. Yeah. So.
Yes.
That's cool.
All right. That's pretty good. That's pretty rad.
Maple Leaf Makers with the trip. The
you guys can see
tips
that.
and tricks. Trips.
I might make a YouTube short about that. That's actually great tricks. You can see it's actually removing more material than the chamfer right there. So you get a nice smooth edge. That's pretty cool. I will definitely be making a YouTube short about that, and I will totally be giving you a shout out for that. That's a great trick.
That's really cool. We have one more
for this
quick
tiny little edge. Not too big of a deal, but for the larger prints, definitely. You had another question?
Or not a question. I think somebody had asked, what is it here? Josh, what project are you working on? And Jake, how's the Strong Beast coming along? So We are
Haven't made
finalizing,
any
as you all
progress.
probably know by now, we're finalizing the second round of our 3D printing course. So 3D printing, maintenance, calibration, kind of advanced techniques.
Assembly, intro to
Way
CAD,
better than
intro
the
to
first
3D
one.
hubs.
Yeah, so we're finalizing that course right now. And we are currently collaborating with 2 other course creators and authors to make a Tinkercad course and an Onshape course. And so to answer your question, PC Van Vliet, I am not working on anything personally except for how to build the next programs so that people can continue to make things on their own. So I've got full help other people make things hat on right now, and I am not making much of anything. Jake, what about you?
I'm currently just doing a million things about editing, and so I'm just making some 3D prints that are representative. Some of you guys may like this. I have a few spools of metal powder filament, so copper prints or copper particles suspended in PLA, so you can print it and you can oxidize it. And so I have a print that I have been patinaing or rusting for a day now. So let me just grab it. It's still in the early days, but I'm printing the Copper Bones key from the Goonies, one of my favorite movies as a kid. This is really delicate. So the patina is kind of coming in really, really wild. So this was originally bright copper, like shiny buffed, kind of a orangey copper. We all know what it looks like. And it's just slowly turning into this really, really wild patina. Cool. I didn't sand it all that much. I might go back and sand it again, but it's just a hydrogen peroxide and vinegar and salt solution. And then you just sprinkle on some sea salt as nucleation points. And it starts to build up this really rad bluey greeny effect on that. There's a YouTuber who does a lot of 3D printing electroplating. I think his name is like Hendrix, but the E is a 3. He makes a ton of really, really kick-ass videos, and he did one about rusting with a bunch like ammonia and crushed up eggs. All different really wild ways to do this, but I'm vegan, so I do hydrogen peroxide solutions. But yeah, they all work really well, and so this will be a little feature. But I'll probably make a little video about how you can do this, because there's a bunch of really weird conflicting information, and there's no perfect recipes on how you actually make this solution. But yeah, this is another project I've been working on. But to finish this, actually no. I was gonna make a new talking point, but I'll leave that for next week.
We got a next week talking point. This has been fun. This has been great,
guys.
Every week, it looks like we're just more and more people are coming in, engaging every week, asking us questions, showing off their projects. So once again, I want a quick plug for show us what you make on the Discord. Put it in the I made a thing. We're going to be putting those in the next iteration of the book. We're going to be showing off what you guys do. So love the photos, love the comments on design, love to see what you're putting out into the real world, even if it's just the projects in the book or a slight modification of those projects. Put it up in the I made a thing. I want to see it. I want to talk about it.
We love to see little projects like this. This is our favorite thing.
Totally. Yes. And I don't know if I got all the questions, so sorry if I missed any questions today. You guys are awesome. Thank you so much for showing up. This has been the CADclass Podcast. I'm Josh.
I'm Jake.
And we'll see you next week. Cheers.
Adios.